Happy morning, students. Welcome to Blue Stars High Secondary School online classes. Previous classes, we have discussed about features of periods and groups. There are 7 periods and 18 groups. So, we have discussed. So, in this class, we have discussed about periodic terms in the properties. So, first one is periodic trends in properties. Unit 8, periodic classification of elements. So anything which repeats itself after a regular interval is called periodic, and this behavior is called periodicity. So in this modern periodic table, some of the interval of after that the element property is same. It is continuous. So this is called periodicity. So what is the properties of the elements are periodic? That is ionic radius, atomic radius, ionization energy, electronegativity, electron affinity. These are the periodic properties of the modern periodic table. Okay. So these are the definitions of periodic and periodicity. Anything which repeats itself after a regular interval is called periodic, and this behavior is called as periodicity. So one by one we will discuss about properties of periodic. Okay, what is this atomic radius, ionic radius? What it mean by atomic radius, ionic radius, ionization energy, electronegativity, electron affinity? We will discuss one by one. Okay. So the first one is atomic radius. Atomic radius of an atom is defined as the distance between the center of its nucleus and the outermost shell containing the valence electron. This is called atomic radius. For we have taken into the one atom, so the center of the nucleus, that is the nucleus contains the protons and electrons. So the distance between the nucleus and the outermost shell, that is L shell. Okay, so L and nucleus distance is called as atomic radius, but we can't directly measure the radius of the atomic radius of an isolated atom. So covalent bond or metallic radius. So these two are the measure the atomic radius. The first one is what is this? Metallic radius and covalent radius. So metallic radius. Atomic radius in metal atoms is known as metallic radius. So metal atom distance is called the metallic radius. So metallic radius is defined as the of the distance between the nuclei of adjacent metal atoms. So this is the definition for the metallic radius of the distance between the nuclei of adjacent metal atoms. So the nearby the metallic atoms, the distance between the nuclei of this is called the metal atoms. So metallic radius. So the next one is covalent radius. In non-metallic elements, the atomic radius is known as covalent radius. So the covalent radius is defined as the same. Okay. So it is of the distance between the adjacent nuclei of two covalently bonded atoms of the same element in a molecule. Same element in a molecule. So this is the definition for the covalent radius. So of the distance between the adjacent nuclei of two covalently bonded atoms of the same element in a molecule, that is called covalent radius. So let us here consider the hydrogen atom. Okay. So the distance between the two hydrogen nuclei of the molecule is 0.74 angstrom. So the covalent radius is 0.74 divided by 2, that is 0.37 angstrom, because of the distance between the adjacent nuclei of two covalently bonded atoms of the same element in a molecule. Okay, so this is the example for the covalent radius. So we are noticed in the modern periodic table, the atomic radius of the elements decreases along the groups, but in the decreases in the period and increases in the group, because the shell number increases the distance between the valence shell and the nucleus increases. Okay. Along the period, so why the atomic size or atomic radius is decreases? Because the shell number is remains the same, but the number of protons is increases. So more and more positive charges is in strong attractions over the electrons, and these electrons cloud shins towards the nucleus. So this is the reason for the decrease in the atomic size. How to decrease the lithium to boron? So this is the valence electrons of the lithium. So this is the valence electrons of the boron. So this is the difference between the two atoms in the atomic radii. Due to the electrons variation, the atomic radius is decreases in the multiplicity period and increases in the groups. So the next one is ionic radii. So it is defined as the distance from the center of the nucleus of the ion up to the point where it exerts its influence on the electron cloud of the ion. Already we know that how the ions are formed. So if the reaction is placed, the atom is lost or gain electrons due to the ions are produced. If the atom is lose the electrons, this atom is called as a positively charged ions, that is cation. So, but the atom is gain the electrons, this is the negatively charged ion, that is anion. So loss or gain depends on the atoms is negative ion or positive ion. If suppose the atoms are gain the electrons, this is a negatively charged ions, that is anion, and the atom is lost the electrons, it is called as positive charged ion, that is cation. Positive charged ion is called as a cation and the negatively charged ion is anion. So the size of the ions is very important for the ionic radii. So the ions are represented the structure of the ionic solids. So the size of a cation is always smaller than its corresponding neutral atoms, but the anion is larger than its neutral atom. So this is very very important, cation and anion. Okay. So in the periodic table, the ionic radii is decreases along the periods and increases into the group. Same for the atomic radii and the ionic radii. So two of the what is this atomic radius and ionic radius decrease the period and increase the group. For example, lithium and sodium lost the electrons from the outermost energy level. So this is the form the what is this cation. Okay. So the ions are formed or smaller because the remaining electrons are at the inner cells and attracted more strongly by the nucleus. And fluorine gain the electrons. So this is the form the what is this anion. So this is the negatively charged ions because the electrons are added to charge on the nucleus. So it's not the great enough to hold the increased number of electrons as closely as it to hold the electron in the neutral atom. So this is the ionic radii. The distance from the center of the nucleus of the ion up to the point where it exerts an influence on the electron cloud of the ion. For example, lithium sodium and fluorine. The next one is ionization energy. Ionization energy is the minimum energy required to remove an electron from a gaseous atom in its ground state to form a cation. So it is called as otherwise called the ionization enthalpy. So the ionization energy is measured in kg per mole, that is Kelvin joule per mole. So if the electrons are removed from the atoms, so the energy is required. So that energy is ionization energy or ionization enthalpy. So the atomic radii that is increases in the period. So more energy is required to remove the electrons. So the ionization energy is increases in the period because more energy is required. So ionization is increases in the what is this period, but in the group ionization energy is decreases because less amount of energy is required. So this is the opposite to the what is this ionic radii and atomic radius because ionic radii and atomic radius the decreases the period and increases the group, but ionization energy increases the period and decreases the group. Okay. So ionization energy is minimum energy is required to be remove an electron from the atoms. This is the ionization energy or ionization enthalpy. So the next one is electron affinity. So electron affinity is the amount of energy released when an isolated gaseous atom gains an electron to form its anion. So it is measured in the same measurement, that is kg per mole, that is Kelvin joule per mole. Okay. So the ionization energy is the cation is formed at this stage. What is this? The minimum energy is required. So electron affinity means that the anion is formed, the amount of energy is released. So that is what is this? Ionization energy is minimum energy is required. So this the amount of energy is released, that is electron affinity. For example, equations. A plus electrons equal to A negative plus energy. So energy is released. Chlorine plus electrons, so chlorine negative, that is the energy is released. So this is the electron affinity. So the electron affinity, electronegativity, ionization energy, this is the increase the periods and decrease the groups. Okay. First one is atomic radius and ionic radius is decreases the group and increases the sorry decreases the period and increases the group, but the ionization energy, electron affinity, electronegativity is the increases the period and decreases the group. Okay. The next one is electronegativity. So electronegativity of an element is the measure of the density of its atom to attract the shared pair of electrons towards itself in a covalent bond. So how to the atom is attract the electrons? This density is measured. That is called electronegativity. For example, HCl. So both the molecules is share the electrons, but the chlorine atoms have a more electron activity and the hydrogen has a less electron negativity. So this picture is representing the bond between the HCl, because these two, that is the hydrogen and the chlorine, to share a one electron to form a covalent bond. So hydrogen and the chlorine atom between the covalent bond here. So but the chlorine is a higher electronegativity because it is pulls the shared electrons towards, and the hydrogen is stronger than the chlorine. So if the bond is breaks between them, the electrons are left to the chlorine. Hydrogen is a positive. So some of the electronegativity of the elements is fluorine is 4.0, chlorine is 3.0, bromine is 2.8, iodine is 2.5, hydrogen is 2.1, sodium is 1. So the electronegativity, it is also a increases in the periods and decreases in the groups. So this is the small comparison of the atomic radius, ionic radius, ionization energy, electron affinity, electronegativity. So periods group. Atomic radius decreases in the periods and increases in the group. Ionic radius same, decreases in the periods and increases in the group. Ionization energy increases in the periods and decreases in the groups. Electron affinity increases in the periods and decreases in the groups. Electronegativity increases in periods and decreases in groups. So these are the small comparisons of properties of the periodic table. Okay, that is periodic trends in properties. So in this class we have discussed about atomic radius, ionic radius, ionization energy, electron affinity and electronegativity. So next class we have discussed about what is meant by metallurgy. Okay, thank you students.